Hello, engineering students. Let's spend today doing a little bit of time getting ready to do something that's important. And I say important because I say, is it fun? No, not necessarily, but is it important? Absolutely. We're going to work today on something that in sometimes science classes is called dimensional analysis. Sometimes it's called a unit conversion, and that's what our project Lead the Way refers to it as unit conversion. First things first, you need to understand what we're doing when we convert one unit to the next or we do this dimensional analysis. So I'm going to do a couple examples with you from your homework, but I'm going to do it fast, and I want you to know the process that we're using so that you can apply that process to any problem. And your first step then is to watch this video, this YouTube link that I made several years ago. I know it's 12 minutes long, but you're going to ultimately save time in the long run when I talk about the process and show you examples, rather than just try to piece how I do one and try to apply it to all the other problems. So you're going to need to watch that first. So go ahead and go to that one first and come back to this video if you need to. Second thing we're going to do then is from your instructor. Your instructor should give you a sheet from Project Lead the Way. We're going to look at this sheet only today. The other side's got something useful for our class, which we'll use pretty soon, which are ideas of statistics. But today we're just going to work in conversions. So when you watch that other video, you're going to learn about this is all about relationships or conversions from one thing to the next. So this sheet's just got a ton of them that we don't have to memorize. So you're going to want to keep this in your binder, fold it, put it in your journal or something like that. But it's just telling us some things that we don't have to memorize. 1 meter is 3.28 feet. 1 pound is 16 ounces. So real simple things like that. The other piece of information that's important on this is the metric system, and it's got all of our metric prefixes for numbers that are less than 1. So if I'm talking about something that's like a meter chopped up into several pieces, these are the prefixes. Or a gram chopped up into chopped up into several pieces, then this is the side we're going to use, right? So if I take a gram or a meter and I divide it into 10, that's what this means. This is 1 divided by 10. And that's as a decimal there, and the prefix would be deci. So a meter chopped into 10 little pieces, each one of those would be a decimeter. This one we're familiar with. If I take a meter, I chop it into 100 pieces, that's a centimeter, right? And the decimal is 0.01. On the other side are things greater, numbers greater than 1. So in this case, if I want to measure a long distance, I might not just use a meter, I might use many, many meters. And one interesting or common one would be this one, the kilometer. So this is 1,000, right? 10 to the third, 10 times 10 times 10. So we're going to use these prefixes and these conversions in our idea here. So the first thing I'm going to do, let's do one real quickly together. I'll show you a simple one. So the first one I'm going to do is the first one on here, and you're going to get this sheet also from your instructor. I'm going to do number 2, actually. So it says we got the strange number, 0.005098 megaliters to liters. We want to convert that. So the first thing we need to do is we have to find the conversion factor. So we want to do from liters to a different type of liters into megaliters. So I'm going to need to look, what's mega actually mean? Well, here's mega. Mega means 1 million of something. So 1 megaliter is 1,000,000 liters. So the first thing I'm going to do is I'm going to write that conversion factor up here for use. 1 megaliter is equal to 1 million liters. And you can write it out if you want. I prefer to use scientific notation, 10 to the 6. 10 times 10 times 10, do that 6 times, that gives you 1,000,000, right? That's why you got 6 zeros in there, liter. So we're going to use this conversion. Now, if you watch the video, how do we do this? I always suggest we use a cancellation line, and we start with something about the relationship that we want our answer to be in. So in this case, we want our answer to be in liters. So I'm going to start with this relationship, and I'm going to put liters up top. So I'm going to put 1,000,000 liters up top. And on the bottom, in the denominator, I'm going to put 1 megaliter. I always suggest then that you leave the given piece of information to last. In this case, what was given? Well, they gave us the amount of megaliters. So I'm going to put that value over here, 0.005098 megaliters. Right? So let's look in terms of the unit conversion of the dimensional analysis. What cancels? I've got megaliter over megaliter. So when I do my math, which is simply going to be 1,000,000 times 0.005098, the answer is going to be in liters. So what does that mean? It means I converted megaliters to liters. All right, so I'm going to pause for a moment there. So when you put that into your calculator, what happens there? I just take 1,000,000, I multiply it by, like I said, that 0.005098, and I get this answer. So I'm going to try to squeeze my answer in here. It would be 5,098 liters. Right? So the answer, this converted into liters, is 5,098 liters. Let's do one that maybe is a little bit more involved. So look at number 3 at the bottom of the page. It says the width of a strand of fiber is 19.2 micrometers. If 1,500 strands are adhered side by side, how wide would the resulting fabric be if measured in centimeters? So we need some relationships to begin this problem. One of the things that we're told is that we know that we have this relationship between micrometers and meters. So again, I'm using my conversion sheet. What does micro mean? So I look down here, and micro means that there's 1,000,000 of something in there. So they're saying that's 10 to the minus 6. Another way to write that would be this way. I could write that relationship either way. So I'm going to write it this way. 0.00000, count that, that's 5,1 meters are equal to 1 micrometer. And the symbol for micro is this kind of little U looking guy. That's micrometer. It's actually a Greek letter mu. Another way to write that, this would be equivalent to this, is 1 meter equals 1,000,000 10 to the 6 micrometers. So we can look at it either way, and either way, depending on, I prefer to do these. I just like the idea of the not 0.00, but we can use either way. We should get the same answer. The other information then we're looking at is, what do we know? We know that we have each strand, so the other relationship is one strand is equal to 19.2 micrometers in length. So again, I'm putting the puzzle together. I want my answer to be in how wide would the resulting fabric be in centimeters. Oh, there's going to be another conversion in here. So I know that in centimeters, I have 100 centimeters, running out of room over here, right, is equal to 1 meter. So the way I suggest to do that, we could do it in several steps, and that's fine, but we can actually do it in one nice problem this way. So I want my answer to be in centimeters. I'm going to start with that conversion. I'm going to start with centimeters on top. So it's going to look like this. 100 centimeters, 1 meter. Next piece of the puzzle I need to do is I need to cancel out the meter. So I'm going to have to put another conversion with meter up here. And I can do it either one of these. I'm just going to choose to use, well, I guess since our conversion sheet uses this one, I'll put this one. So the answer with this would be 10 to the minus 6. That's what this value is in scientific notation. To 1 micrometer, right? So now my meters cancel. Now I got to cancel out micrometer in this case. So I have this relationship, 19.2 micrometers per 1 strand. So 19.2 micrometers per 1 strand. And then I finish it off with that last piece of given information, 1,500 strands. So strand cancels strand, micrometer cancels micrometer, and once I carry out the math, 100 times 10 to the minus 6 times 19.2 times 1500, these are all ones, so I just divide by 1, divide by 1, divide by 1. The answer is going to